Hi, in the last session, we talked about the scheduling in 5G NR. We've seen how different scheduling processes are ideal for different needs and different use cases, and what should be used for mobile broadband applications and what should be used for low latency applications. Now, let's understand the concept of quality of service, QoS. We will understand its importance and the basic principles of QoS. Well, QoS concept is not new. It is already being used in 4G LTE, but we will know that how it is evolved to meet the demands of 5G networks. So let's start. Before understanding 5G QoS, we need to understand what is QoS or quality of service. In short, quality of service offers the ability to manage different type of traffic, which has different network demands and different requirements from the network. And it ensures that each type of traffic gets the appropriate level of resources and services. We will be understanding this in details in some time. So a network can handle different type of traffic, which have different requirements. For example, a voice call should be treated differently than a data transfer service. Same for a video streaming service. All of these use cases requires different levels of service to function properly. Sometimes even a single user device may need multiple connections simultaneously, and each for different type of traffic, such as voice, video, and data services. For example, when a user device or a UE makes a voice call, it needs a continuous delay sensitive stream for data, but that requires relatively low data rate. But for some heavy file transfer, UE requires a different type of connection, which can handle bursty data traffic. So this type of service is less sensitive to delays, but that should offer higher data rates, right? So this brings the need of quality of service, where different type of services can operate efficiently and meet user expectations. A QoS parameter defines some critical characteristics or parameters. For example, what is permissible packet delay, what is acceptable packet error loss, and other metrics that determine the quality of connection. So, how does the network manages and prioritize the traffic from these different type of services to maintain the required QoS? One of the fundamental requirements for communication in any network is to obtain an IP address to a UE. One UE can be assigned one or more IP addresses depending on the services it needs to access. In 2G and 3G networks, obtaining an IP address was referred as establishing a PDP context, where PDP stands for Packet Data Protocol. In 4G, this operation is referred as establishing a PDN connection, and it is managed using the concept of barriers. A barrier is simply a dedicated transmission path through the network with some defined capacity and latency and packet loss kind of characteristics. You can assume this barrier as a concatenation of various tunnels in the radio access network and the core network. So this complete barrier links the UE to the packet data network. Now, if there are multiple barriers established, then each barrier is associated with some specific QoS level, which ensures that the service requirements are met. In 4G, a default barrier is automatically established to a default packet gateway when the UE is powered on and has successful authentication. Every PDN connection in 4G has at least one default barrier to handle the basic traffic. In addition, dedicated barriers can be set up whenever they are needed, such as when there is a need for voice call or need of data transfer or online gaming, etc. In 4G, QCI or quality of service class identifier is the parameter which is used to define the specific QoS characteristics for a connection. Depending on the QCI values, there are two kinds of barriers. The first one is called GBR barrier or guaranteed bitrate barrier, and the another one is non-GBR barriers or non-guaranteed bitrate barrier. Now this table is the relationship between the QCI value and its corresponding barrier type and packet delays and packet error rate. In the radio access network, scheduler looks for this QCI identifier to set the right priorities to achieve the QoS parameters like delay and error loss, etc. for all the services it is serving. Similarly, in the core network, routers and switches also use QCI to manage the traffic priorities and maintain the QoS. In 5G, this process of obtaining an IP address is now referred as establishing a PDU session, where PDU stands for Protocol Data Unit. One single UE can also have one or more PDU sessions, depending on its needs. In 5G, the concept of barrier now has been replaced by QoS flows, although they serve a similar purpose. So each PDU session in 5G can have one or more QoS flows, and each PDU session corresponds to the different quality of service performances. Just like barriers in 4G, QoS flows in 5G also have a series of tunnels throughout the network, which are configured to meet the specific service requirements. The difference in 5G is that there is only one entry tunnel per PDU session. In 5G, different ADU barriers corresponds to different quality of service performances, and all are mapped to the same N3 tunnel in the given PDU session. In 5G, the QCI parameter is replaced by 5QI or 5G Quality of Service Identifier, although their concept is same. Now, based on the 5QI value, 5G networks have three kinds of barriers. So 5G has one extra QoS compared to the 4G QCI. So these types are guaranteed bitrate or GBR, non-guaranteed bitrate or non-GBR, and the third category is known as delay critical GBR. This is specifically designed for ultra reliable low latency communication or URLLC use cases. Okay, so that's it for today. We have explored the principles behind the QoS in 4G and 5G. We understand that how the networks manages different type of traffic to ensure the appropriate level of services for various applications. In the next session, we will be talking about one of the 5G use case group, that is massive machine type communication. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.